Imagine a quiet rainforest. You can hear the birds chirping. The soil underneath your feet is moist. Looking around, you see an ethereal cloud engulfing the trees. This is not a scene from a sci-fi novel. This is a cloud forest right here on Earth. Cloud forests, also called tropical montane rainforests, are tropical rainforests in mountainous regions, which experience heavy rainfall and condensation, giving them a constant cloudy environment. These clouds happen because moisture-carrying air is deflected upward by mountains. As we travel higher in altitude, the temperature decreases, and the water vapor, or the water in the air, starts to condense into water droplets that form clouds. Due to these reasons, they have a higher humidity and lower temperature than other tropical forests. These forests are found at altitudes of around 1,000 to 2,500 meters, or some sources say 2,000 to 3,000 meters. Throughout the year, they experience a layer of cloud around the canopy. The canopy is the uppermost layer of trees or branches and leaves that create a roof over all the other plants and the forest floor. Such majestic and mysterious forests can be found in Central and South America, Eastern Africa, and Southeast Asia. Taking a look at this map, we can see cloud forests are not very common, as they are very sensitive to abiotic factors. Abiotic factors are non-living aspects that affect the biome. The abiotic factors affecting cloud forests are sunlight penetration, humidity, rainfall, cloud immersion, which is how much of the forest is immersed in clouds, temperature, soil, nutrition, elevation, wind, air pressure, and distance from the sea. On the other side of the abiotic factors are the biotic factors, the living aspects that affect a biome, the flora and fauna. The flora, or vegetation, in this environment has adapted to such high amounts of humidity. The trees in this region are shorter, tightly packed, and with dense stems, and the leaves are thicker, harder, and shorter. There is also an abundance of epiphytes. Epiphytes are plants that grow on other plants or objects for structural support without harming them. In cloud forests, they get moisture and nutrients from the air and rain instead of the soil. Some examples of epiphytes found in these forests are a variety of mosses, lichens, climbing ferns, orchids, and others. However, there is a decreased diversity of woody plants. Although there is a lot of diversity in animal species, because of microhabitats, which are slightly different, small habitats, at different heights within the forest. Some honorable mentions of these animals start with the rarely seen clouded leopard. They are admired for their secretive nature and unique patterns. Next is the resplendent quetzal, a bird with stunning colors which were a sacred symbol in Mesoamerican civilizations, and the spectacled bear, which is the only bear species native to South America. Some other notable animals include the ochre-fronted antpitta, hummingbirds, long-whiskered owls, yellow-tailed woolly monkeys, long-limbed salamanders, and the native species of Geoffroy's spider monkey. We could name more, but we would be here the whole day. Adding to the significance in biodiversity, cloud forests are crucial for some biogeochemical cycles. Biogeochemical cycles are simply cycles of chemicals that are important to biology in geography. This biome is very important for the functioning of the hydrological cycle, or the water cycle. We first start at the top. The forests gain water by fog stripping, which is when the canopy and trees absorb the water from the fog. This water doesn't evaporate out of the forest because of the high humidity. The evaporation happens at a lesser degree than in other forests. Then the fresh water can be transported to a waterbed below through soil as infiltration or a stream on land as a runoff. The water either goes to a larger body source like rivers or oceans, or evaporates back to the top of the mountain where it can condense as fog or dew. This biome also helps in the carbon cycle because of carbon sequestration, but we will not go into that in this video. Now that you understand the significance of cloud forests in biodiversity and biogeochemical cycles, let me tell you about the threats they are facing. Cloud forests fell from making up 11% of the global woodlands in 1970s to only 1% in 2022. One source claims that around 55% of the original area of cloud forests has been lost. This decline can be attributed to deforestation and climate change. as the global temperature increases, because hot air rises, the warmer clouds go higher up, which leaves parts of the cloud forest dry. This biome hasn't received the amount of research and study that other biomes have because of its remote location and terrain. Along with the damages done by deforestation, global warming is changing the cloud structure of this biome, which affects its delicate microclimate. Warmer climates increase the altitude at which cold condensation of water vapor occurs, increasing the height of the clouds, and hence increasing evapotranspiration in the air. Evapotranspiration is the total water that moves from the land and goes into the air. Evaporation from the ground and transpiration from the plants. The cloud immersion of the forest is necessary because if not, they are more susceptible to fire, diseases, and other invasive species. Additionally, some projections say that cloud immersion could decrease or dry out in 57 to 80% of neotropical cloud forests. Since the forest plays a crucial role in water cycles, any disruption could cause reduction in water availability in lower parts of the watershed, or water that flows down from the mountains. Research done by the Global Forest Survey in 1990 shows that approximately 1.1% of the tropical and highland clouds are lost each year. Some estimations say that in the next 70 years, the environment that forms cloud forests in countries like Mexico will completely be lost. There is still hope. Many local communities are working to protect these forests. One key strategy is to establish protected areas, which include national parks and reserves. Involving the local community who live near and inside the forest can allow the balance between conservation and sustainable living. Local communities can't control climate change, however, they're committed to helping in the ways they can. Take, for example, the Aconcagua community fighting for El Triunfo cloud forest in Mexico. It is one of the most biodiverse places in Mexico and contains many rare species of animals such as the aforementioned quetzal and the endangered horned guan also can be found. The Aconcagua have created obstacles and forced mines to shut down in El Triunfo. Many other works to raise awareness about the forests and can become guides to connect people to nature. The UN Environmental Programme World Conservation Monitoring Center is taking measures and has declared 327 out of 700 identified cloud forests as protected areas since 2002 to help protect and conserve these ecosystems. Although difficult, botanical gardens in Singapore and San Francisco are trying to recreate the natural conditions of cloud forests artificially and encourage growth of plants including ferns, orchids, and club mosses. All of these actions can only delay or slightly reduce the negative effects on cloud forests. The main source of the problem is global warming, which needs to be addressed. It is a worldwide problem that affects every biome and environment on Earth. Every little environment is a cog in the machine that runs the planet. Each piece has its importance, and climate change is taking the whole world down by attacking these under-researched biomes. Therefore, you, as a more educated viewer, should raise awareness about climate change and show support for actions that make this planet better for everyone.